Today we're talking about 10-4 infinite geometric series. So it's still geometric, where we're still looking for what? If it's geometric, what's the one letter that's pretty important? R, right? So it still has R, it still has an a sub 1, all that stuff is still the same, but this time it's infinite. So infinite, you should know by now, infinite geometric series is an infinite number of terms. So do you see how all of these have like a dot, dot, dot at the end? That's to let you know that they continue for forever, okay? They don't stop. Convergent series is a series that has a sum. Divergent series is a series that does not have a sum. So, sum of an infinite geometric series. If r, the absolute value of it, okay, we don't care if it's negative or positive. So, if the absolute value of r is less than 1, it has a sum, and you plug it into this formula where s equals a sub 1 over 1 minus r. Do you guys see that on your formula sheet at the bottom? Okay, so I even gave you, I believe, this part too, right? To let you know if it exists or not. And if it's greater than or equal to 1, there's no sum. Okay, does everybody see what I'm talking about? That is just for infinite geometric series at the very bottom. So your arithmetic is those first three. Your geometric is the second set of three, I think. And then right below that is these, right? Okay? Your convergent and divergent. So that's it. We're just going to do a couple. All right? Determine whether each infinite geometric series is convergent or divergent. So again, they said infinite geometric. So because they said that, it's not the second set of three on your formula sheet. Do you guys get what I'm saying? It's the bottom ones. Okay? So in order to figure out if it's convergent or divergent, we need to know what? R. We have to know R, and that's not new to you, right? So go ahead and find R on number 17. And what do you get? What? What'd you get? 3 over 4? Should get 3 over 4. Because 360 divided by 480 is 3 over 4. Does that make sense? Okay, so now we look at our options. So it's already positive, so I don't have to worry about the absolute value part, right? So is 3 over 4 less than 1 or greater than or equal to 1? It's less than 1. So because a sum exists, is it convergent or divergent? Convergent. Do you guys understand how I use that information to figure out the answer? Okay. So there's a couple of things that I added in the notes that might be a little bit less confusing for you. Let's go ahead and pause here and just do that. I went ahead and say that this was convergent, so I knew right away if there was a formula, then it was convergent. And then I kind of like put a slash here, so I knew that this was the divergent answer. It's not that you can't look above it and figure that out, but I feel like that was a little bit easier to understand. And you guys have a line here, right? Yours doesn't just say greater than, it says greater than or equal to. Okay, good. I couldn't remember if I added that to yours or not. And then the other part I added in is, this makes sense to me, but for some people, they didn't understand what that answer could be. If it's absolute value, then r is less than 1. That's still true. I think you guys get that. But it also would mean this. It's in between -1 and 1. If you go way, way, way back, if you solve that, you set up two inequalities, and you have to flip your sign on the second one. So this here means the same as this here, -1 in between, or r is in between -1 and 1. Sorry, it's hard to read now, but you don't have to know that. I'm just saying some people don't understand that this means the same as that. Okay? All right, back to 19. We have to find what? R. So find R. What do you get? 4/3, same thing, right? R is 4 over 3, or 1 and a third. Is anyone not getting that and need help? For sure? Okay. So is that, again, it's positive, so we don't care. Is that in between -1 and 1, or is it greater than or equal to 1? It's greater than or equal to 1. 4/3 is 1 and a third, so it's bigger than 1. So that means it's divergent. Anybody confused? Okay, great. Find the sum of each infinite series if it exists. So they said infinite, so what we know is we have to use these formulas at the bottom. If they hadn't have said that, we wouldn't have known. okay? So when they say infinite, it means don't use the middle three, use the bottom ones, okay? So again, what do we have to know? We have to know r because there may be no sum. I don't know. I've got to figure that out. So find r first. And what do you get? 1.4? Anybody not getting 1.4? Okay. So again, if that is, where are we at? I'll have to go back up, sorry. Is that in between -1 and 1, basically is what that means? Or is it greater than or equal to 1? Greater than or equal to 1. So, no sum exists. Everybody okay? Okay. Find r for number 25. What'd you get? 1/2. Good. So 1/2 is less than 1, right? It's already positive, so I don't care about the absolute values. So that means a sum exists. So I have to use this formula. S equals A1 over 1 minus R. So what's A sub 1? 12 over 5 over, bless you, 1 minus 1/2. Use your calculator and see what 12/5 divided by 1 minus 1/2 is. And I get 4 4/5. That's the same as 20 over 5. That's the same as 4.8. Those are all the same. It doesn't matter how you write it as long as you're not rounding. Is anyone not getting 4 4/5? I know it's easy to do, but if you don't plug it in on your own calculator, you might get it wrong. Anybody need help? Okay, great. Number 29. On this one, I know it's geometric because of the way it's written. Remember yesterday where we had a number times a number to the k minus 1, right? And this is infinite because it goes to infinity. Do you understand? That's why I know I'm going to use these formulas at the bottom, okay? So when we do this, we need to know r. Remember the trick from yesterday? What's r without doing any math at all? It's the 5 over 4. Yeah. Do you guys remember that's the 5 over 4? Usually this is A1 and usually this is R. Usually A1 from yesterday and usually R. If you wanted to actually figure it out, you could, okay? Let's see if we even need to though, right? So if it's 5 over 4, does the sum exist or not? Yeah, no sum exists. Because 5 over 4, 1 1/4 is greater than 1. So no sum exists. Is that okay? Okay, next one. What is R? 3 over 7. Does the sum exist, yes or no? Yes. So I need S equals that A sub 1 over 1 minus R. I don't know what A sub 1 is yet, but I know R. So again, from yesterday, what's A sub 1? 5/3. If you don't feel confident that you're going to remember that, you don't have to. Okay, so pause for 2 seconds before we find the answer. If you know you're never going to remember which one's which or you're going to get them confused, you could plug 1 in for K, and that would give you your first term. If I plug 1 in for K, this becomes a 0. Anything to the 0 is times the 5/3. 5/3. So A sub 1 is 5/3. Do you guys get that? If I wanted to figure out R, and I didn't feel confident that I memorized it, couldn't I find the second term? So plug 2 in, you'd get your second term, and then you could figure out R by working backwards with division, just like you did on a couple of questions ago. Am I making sense? Memorization is awesome if you're good at it. If that's not a gift, then don't. Plug in 1, plug in 2, find out R that way. Make sense? Okay, so what did you get if you already did it? 2 and 11 over 12. Or 35 over 12 or whatever. I don't know what kind of decimal that is, but. Anybody confused? Okay. Why don't you try this next one completely without me? Number 45, do it all without me. Find R, see if a sum exists. If it does, plug in the formula. I'm going to do one little thing at a time. What is R on this one? 2/3, very good. So does the sum exist? Yes, so S equals, what was A sub 1? 15/4 over 1 minus 2/3, which is 11 1/4, or 45 over 4. 29. 29 did not have a sum because this is bigger than 1. This is 1 1/4. So if you go back up to the top, bigger than 1 is no sum. And 1 1/4 is bigger than 1. Does anybody have a question? Okay. These bottom couple, it's no longer in the standards. I mean, I'm not saying it won't come back someday, but for now it's not. And if it's not in the standards and we have time to skip it, I skip it. Okay. So that's it for this section. Okay? Actually, we're